What's up, colleagues? Today we're going to talk about decorators. But before we start to talk about the tool, we should discuss the purpose of it. Let's start with the fact that once you've coded an application, you will support it for a long time. You will add and modify features, fix bugs, work on performance, etc. That's why you better write easy supportable code. It means code must be reusable and you should avoid copy-paste. OP and inheritance classes help us to avoid code copy-paste when we are dealing with objects. But what about functions? This is the reason of decorator's existence. Look at the screen. You can see different functions that perform different stuff. Now I wanna make them print information about each call, let them print their name, arguments and return value on each call. And for sure we are not going to copy-paste any code responsible for printing. To be able to design a decorator, firstly we need to learn some new syntax. Look at the screen. This function takes arguments using *args and *kwargs. Let's call it with some positional arguments and some keyword arguments. As you see, all positional arguments have been thrown to the tuple args, and all keyword arguments have been thrown to dictionary kwargs. Moreover, naming args kwargs doesn't matter, but single star and double star are essential. All positional arguments always go to a single star tuple, and all keyword arguments always go to a double star dictionary. Also, it works in reverse. Look at the screen. You can see the function which takes 3 positional arguments and 2 keyword arguments. And there is a tuple which contains 3 members and the dictionary with 2 keys. Now I am calling the function throwing the tuple through a single star and the dictionary through a double star. All the tuple's members are taking place as positional arguments, and the dictionary's members as keyword arguments. We've just literally unpacked the tuple and the dictionary as the function's arguments. Now there is one more essential thing about functions in Python. A function is an object, a special object that can be called using round brackets. But if we skip writing brackets, a function does things like a regular variable. Look at the screen. We've defined the function foo, then we've put it to the new variable, skipping brackets. Then we've called this function, typing the new variable and brackets. The same way we can put functions to data structures. Look at it. We've put a function to the list, then extracted it by index and called it. But that's not all. A function can accept as argument any other function. Look at this code. There is a function named wrapper. It takes any function as a first argument, then *args, *kwargs. Within itself, wrapper calls any function with args kwargs and can perform any action before this call and after this call. Let's place print at these actions. Yeah, function has name property which contains human readable name of function. Now we can call wrapper passing at the first argument any function in the world, and the function will be called with actions defined in wrapper. For example, we've defined a function sum that takes 2 arguments. Let's pass it to wrapper with couple numbers. As we see, some calculated numbers, but also we got these prints. But this is still not enough. A function can return some new function. Look at the screen. We defined function printDecor. It takes any function as an argument and returns the new function wrapper. Wrapper calls this any function, but also perform prints before a call and after a call. As you see, decorator basically is a function that takes another function as an argument and returns a new one. Usually a new function calls the old one and makes some action before a call and after a call. Let's apply decorator to functions from the very beginning of this video. Look, I've just replaced source function by wrapper returned by print decor. And this new function do the same as source functions, plus prints on every call. Now let's make the code a little prettier. Python has special syntax for applying decorators. Look, we just wrote add sign and decorator's name above source function definition. It's equivalent to this code. Also, I've renamed print decor to printable. Once a programmer saw the decorator named printable is applied to a function, they will realize that this function will print an additional stuff. Looks like we are almost done, but not completely. What if I want to apply more than one decorator to a function? Firstly, let's write a new one. This decorator takes the time of source function's execution. It checks a time before a call, then after a call, subtracts the other from one and gets a duration of a call and prints it. Now we can apply the second decorator to a function, run it, and as we see, the name of source function was changed to wrapper. Why? Any ideas? Let's see. What is the first decorator returning? Right, wrapper function. So the second decorator was applied to this wrapper function and printed its name. What can we do with it? Right, we're just replacing wrapper's name with the name of source function. And it works. But there is a thing. Functions contain a lot of meta information besides a name. Fortunately for us, there is a special decorator that transfers all meta from one function to another. We're just importing it and applying this way. Checking. Perfect. As you see, this decorator can take arguments. What if we want that too? Let's try to do it the most naive way. We will just write some decorator which takes additional arguments besides source function. Look at the screen. This decorator tries to call source function in case of failure attempts again. A number of attempts and sleep time between attempts we are passing to arguments. Now, if I try to apply this decorator, I will get this error. Yeah, decorators in Python can take only one argument. Is there anything we can do with it? No. But yes, of course we can. Actually, only physics laws limit us. We will just write the function with needed arguments, and this function will return the decorator. As you see, decorator uses those arguments in its logic. Look, I am calling this function passing 3 to attempts and 1 to sleep and get this decorator, which will make 3 attempts and 1 second sleep between them. Now I can apply it. Or I will just keep defining a decorator and put this call here. This trick is also called a parametrized decorator. And the last thing for today. Sometimes we want to put some variable here and change it inside wrapper. Let our with attempts decorator calculate all failure calls. So I will put the counter here and will increment it here. As you see, PyCharm highlights it in red. If I run this code, I will get an error. Yep, in effect, this is an unlocal scope. And variables can be rewritten from the scope. Besides, I will not do it explicitly. using Nonlocal special word. Now it works. For today we are done. Now you see the main points of this video. I would appreciate if you like this video and wrote something in commentary. Adios us!